Great, and let's get it started. All right, hello friends. Good morning, good morning. I would like to welcome everyone to Community Talk 21. We have an amazing lineup of speakers today and some wonderful community updates. Stay tuned for segments on file data sources, the testnet launch of Base, ETH Denver, Subgrounds, and scaling on Arbitrum, and also AI in crypto. Before we get to these segments, I would like to inform you about a multitude of community updates. In the Graph Advocates program last month, 24 new Graph Advocates were onboarded from Nigeria, the United States, and the Middle East, and they joined the team to make some great contributions. Graph ecosystem participants will join eTokyo from April 14th to April 16th. The Graph will sponsor $7,500 in prizes at the hackathon. So make sure to reach out to us if you're participating in eTokyo. We would love to meet you there. After eTokyo, the Graph will also be represented at the recently announced ETH Lisbon. The Graph will sponsor $10,000 in prizes at the hackathon. So make sure to reach out to us if you're planning to attend ETH Lisbon as well. A newsletter for developers written by Simon from Node has been released, and a lot of the links to those the prizes and sponsorships and everything else will be released in the chat room here and will also be added to the description of the recording. The Graph Foundation released the reports of the grants in 2022, and that link will also be shared in the chat. There are a multitude of open roles in the ecosystem, and if you want to be informed about the open roles and about the upcoming roles, make sure to follow Matt on Twitter or go to thegraph.com/jobs. There have been 4 new releases of the GRTIQ podcast since the last community talk. We had 105, Scaling on Arbitrum, the Graph's move to L2 and how it will impact the Graph network, with Ariel, Daniel, Pablo, and Simone. Then we had 106 AI in Crypto, which was a panel about AI in crypto with Anirudh, Sam, and Thomas, who explored what artificial intelligence is, the origin of the discipline, and the epic and how it works. We will also hear from Sam later in this call, so already thank you for joining, Sam. We had episode 107 of the GRTIQ podcast with James Hall, design manager at Node, and episode 108 with Darby, who is a Graph advocate and a member of the Graph Advocate staff. So make sure to check out these episodes, they were really cool. I'm also pleased to announce that the text translators in the Advocates program have finished translating of the Graph documentation to Spanish, Hindi, Japanese, Portuguese, and simplified Chinese. So really good job to all of the advocates. The translations still need to be proofread, so if you speak any of those languages and you want to help out, feel free to reach out to the members of Advocates now so we can get you on board to the program. Before we move on to the segments, I would once again like to give a big thanks to all of the community members that helped out at ETH Denver and that helped out with the translation of the documents. Our first segment is about file data sources, a feature that enables developers to seamlessly fetch and filter NFTs by the metadata. And to explore that more, I would like to pass the mic to Simon from Node to talk about this new feature.
Yes, hello. Can you hear me?
Yep.
Cool, amazing. Thanks, welcome. Hi, everybody. Thanks for the opportunity. So, file data sources, it's actually for me one of the most exciting features that we recently launched on the decentralized network with GraphNode version 0.30 that is rolled out now to the network. There's this new possibility of indexing IPFS data. Before we had like IPFS data was existing before already, like the subgraph developers were able to create or like download data from IPFS and parse it in their subgraph. But the problem with that approach was that it was blocking. Blocking means that whenever there was an event or another information that the subgraph indexed that said, hey, you need to download that file from IPFS, the graph node stopped like indexing further blocks until that file was retrieved. And because due to the nature of IPFS, that files might sometimes they are quick, but sometimes it can take like hours for them to be retrieved. That made some subgraphs like never catch up, and that was actually a problem. Also, this implementation was indeterministic, so we were so it was not available on the decentralized network. Now, Leo mostly and Adam from Etchnode, the GraphNode team, rethought the whole thing and built the file data sources in a way so that they are so the process happens actually in parallel. So the main shift is that when a subgraph tries to download a file from IPFS, or actually new file data sources are upcoming, we're looking also at Arviv and others, then a new process kind of is spin up in the background that tries to retrieve that file. And when that file is retrieved, then a special mapping will be run. The default process can still continue to index. So like when we see a block that would trigger an IPFS download, the GraphNode can just go on, and in the background will be triggered as soon as that file is available. That also gives some data, like that also a little bit, it's the first step into some indeterministic data sources, because it could be that one indexer is able to retrieve that file, but the other isn't. Also due to the decentralized nature of IPFS, but with the whole architecture is set up that we can now have entities in subgraphs that are not necessarily deterministic, which is super exciting, because actually non-deterministic data also opens up like a wide array of new use cases for subgraphs and the graph. I don't think that we should go more into the technical details of the implementation. I think the best thing would be to just read into the link that was shared here. Let me see if that makes sense. Yeah, that's a good one. Or otherwise, there is also documentation on the Graph Official Docs website. And always you can come into Discord and ask questions about this, and we're more than happy to help.
Thank you so much for that explanation, Simon. Super exciting stuff. For the next segment is about the Graph's collaboration with Coinbase for the testnet launch of a new L2 called Base. I would like to pass Pranav from Edgenode to talk about this collaboration and also about his workshop at ETH Denver. Pranav, it says that you're unmuted, but I cannot hear you right now. We cannot, no, not yet. Yep, that's completely okay. All right, so we'll switch around these segments for a little bit. It's a good segue anyway. We can do them the other way around. So our second segment, which was the third one, is about ETH Denver. The Graph hosted a very extensive workshop at the University of Colorado at Boulder. We had a lot of speakers at this workshop, including Kyle, Simone, and Ricky from Edge and Node, Orion from the Graph Foundation, Rad from Missouri, and Gogai from Semiotic. So we covered a lot of stuff about the graph and about how the students could use it. We also hosted a small hackathon there, so the students had a great time and started building right away. And then also the graph had a booth at ETH Denver. The team there, where we had like 40 people there, so it was amazing. The team spoke to thousands of attendees and hundreds of protocols and projects. The graph also sponsored the hackathon bounties for the building of the best new subgraph and the best use of an existing subgraph. And one of the teams that was building on the hackathon at both the University of Colorado at Boulder and ETH Denver was Chainbrain. And I would like to pass the mic to Marissa, who was at both the events, to showcase their project and tell us about it.
Awesome. Yeah, thank you so much. I'm just going to share my screen here. Can you guys see my screen?
Yep. Looks
Awesome. Cool. Yeah, like Colson said, we were at both the UC Boulder hackathon and ETH Denver, where we built Chainbrain. So I was inspired to build Chainbrain throughout my work as a data scientist when I became frustrated at constant requests to pull data for non-technical users. So we built Chainbrain, which is a no-code analytics platform that allows users to easily search and generate visualizations for any blockchain data question. So users can ask ChatGPT a question and we'll generate a visualization showing the results. So we built this on top of the graph protocol subgraphs. First, we used Masari subgraphs because they had a more defined and uniform schema across different types of subgraphs. So, for an example, let's say that I'm an NFT trader interested in daily trade volume over time. I can type in how many daily active traders were there over time. I just typed this in advance just so it wouldn't take time to load. And I can see here a graph that shows daily active traders, the daily traded collection count, and the daily traded item count. And I can see how this varies over time. And I could use this if I'm looking at good times to buy and sell, etc. So this is one of the use cases. And basically how it works is our AI model will interpret the question, and based on training data that we provided the model, it will create a GraphQL query that we send to the subgraph in question. The result is then parsed and displayed in a visual output for the user to see. So we also have a functionality to save it to my dashboard or check whether this is an expected result. So I can go ahead and save this to my dashboard, and then I can go in and view all of these queries that I've saved. So for another example, let's say that I'm interested in lending, and if I want to search the Uniswap subgraph, I can go ahead and I select it here, and I can search what are the top 5 USDC pools by volume. And we generate this GraphQL query that we show to the user just in case they want to go in and query it on the Graphs Playground or maybe change some things themselves. And in this table, you can see the cumulative volume USD and TVL USD sorted. So maybe I want to get rid of my USDC through Uniswap. I can look at the top 5 pools by volume and see which one I like the most to use it to exit from my USDC position. Normally, you could just use the biggest pool, which has the least slippage. But in this case, the biggest is ETH, which also has some price volatility. So maybe I want to do the third pool, which is Tether, which has a really low fee of 10 BPS. So then I could go into Uniswap and based on this, choose like which pool I want to swap in. So this is just a really quick overview of Chainbrain. If anyone is interested in learning more, you can reach out to me on Discord and I would be happy to chat with you. We will be continuing our development of Chainbrain, and currently we are looking for a machine learning engineer with a background in natural language processing. So if this sounds like you and you're interested in getting involved, please do reach out.
awesome. Thank you so much. I think there was a question in chat by a colleague. Maybe he wants to ask it.
Yes, that is the query that is used to get the data in the chart. We display that to the user so that if they want to go in and edit that in the playground, they are able to if they want to play around with it. But at the end of the day, Chainbrain is for non-technical users to enable them to get the data they need without knowing how to code. And another aspect of this is maybe once users are seeing all of this GraphQL code, they can start to learn how GraphQL works, and we could onboard more technical users as well.
That would be great. How can people get in contact with you if they want to know more or they want to apply for the position?
Yes, you can message me on Discord. I will write hey in the chat so that everyone has my Discord.
Awesome. Thank you so much for that presentation, Marissa.
Thanks.
So let's check once again if Pranav is online.
Guys, can you hear me?
Yay, Pranav, hi. How are you?
Oh, yay, finally. So, good, good. Really, really, exciting times after ETH Denver. ETH Denver was really successful and was really happy to meet a lot of people from Graph Advocates, the Graph Foundation, and EdgeNode and other core devs. And there we also did a presentation on base, and on 21st, that is one day before on 23rd, I guess, one day before the starting of the build week at ETH Denver, we we announced the partnership between Base, which is the new L2 by Coinbase, and the Graph. And basically what we did is that now people on who want to deploy a dApp on Base testnet, which is L2 of the Coinbase, can now deploy a subgraph on the Graph Studio, of course, in a rate limited environment, on the Graph Studio, of course. And basically, I did a workshop for this. If you want to have a subgraph or your testnet at base, all you need to do is go on the Graph Studio, have base testnet as the selection, and then in the manifest name, use base testnet as the network name, and you should be able to deploy a subgraph. Coinbase also had a really big booth in the ETH Denver place, and what I did is did a workshop on how you can deploy a subgraph on Base with the help of different tools around the Graph Studio, including Graph CLI. And basically, we also updated. The most important point to note here is that we updated the Graph CLI version support base. So if you are on a not the latest version of the Graph CLI, you might not be able to index, or you might not be able to deploy a subgraph on the base testnet. You will have to update your version so that you can deploy a subgraph on the base testnet. And of course, it's a very exciting time because Coinbase is a very predominant exchange in US and around the world, and they have launched a chain which is a OP stack chain. So a lot of people would have interest, and institutions would have interest in doing things with base, and having support the graphs on base in itself is a great accomplishment, since a lot of these institutions and dApps will start deploying their subgraphs on, and you start using the graph for their indexing needs. That's it. Thank you.
Great, thank you so much, Pranav. And if Subgraph developers have questions about it, there is this new base Subgraph channel under the Subgraph support in the Graph Protocol server. So if you have any questions, you can reach out there, and people will help you with your base Subgraph. So thank you once again, Pranav. For our fourth segment, I would like to introduce Subgrounds, which is a way to access subgraphs using Python instead of GraphQL. And I would like to pass the mic to Tachi from Playgrounds to talk about Subgrounds.
Hey, thank you. Hello, everyone. Thanks for the opportunity to talk about playgrounds and subgrounds and how we're helping everyone do data analytics with their subgraphs. So I'll go ahead and share my screen and kick things off. I put together a little slide to get started. Let's go. Awesome. So my name is Tachi. I'm one of the co-founders and CEO of Playgrounds Analytics. And in today's conversation, I'll be going over, subgraphs for data analytics. Is that possible? The challenges that most users face today when trying to do real analytics with your subgraphs, a proposed solution, which is Subgrounds, and is Subgrounds for you? And of course, I'll end it with a quick demonstration on how you can go from zero to hero using Subgrounds. So, who are we at Playgrounds? We're essentially a data solutions company that provides easy and reliable tools for blockchain data analytics using your subgraphs. And our goal really is to provide the easiest way to do real analytics with your subgraphs. But why subgraphs for data analytics? And it really does come down to three things, honestly. It's easy to standardize your indexing and your queries across multiple sources. It's also easy to scale your subgraphs to handle more loads and more needs over time. And subgraphs are honestly very flexible, providing you the ability to modify them and upgrade them as your needs expand. So there's quite an opportunity here with subgraphs beyond just powering dashboards for dApps, but actually being a tool to do real on-chain data analytics with the subgraphs as well. But of course, there are limitations to using subgraphs to do analytics because it's written for GraphQL. That's how you interact with subgraphs. And because of GraphQL, you're faced with most people are faced with this steep learning curve of having to understand and work with GraphQL strings. There's limited functionality when it comes to using subgraphs and GraphQL. And of course, GraphQL is quite complex. You need a lot of time to understand the structure, and even at that, it takes a lot of time to construct the right query to tell a meaningful story from your on-chain data. So that's why the prevalence or the growth of subgraphs for true data analytics is not quite as popular. But at Playgrounds, we're saying it can be easy and it should be easier, and we're building the tools to make that possible. And the philosophy behind making a solution that's possible basically falls under three categories. It has to be simple, it has to be open source, and it has to be familiar. Simplicity being it's easy to understand, it's easy to read, it's easy to work with. Open meaning it should be customizable because everyone's data needs vary from business to business, from analytics to analytics, from protocol to protocol. It all varies. So providing a library that's open source and truly customizable and extensible is key. And of course, familiar. We wanted to provide a tool that works with the tools that you're already familiar with, like Plotly, or getting a CSV file out of your query, or using charts that plugs into a Python environment natively. Using these three categories, we truly believe that we can unlock true data analytics with your subgraphs. So how are we answering that question today, and how are we meeting these three categories? Well, that's Subgrounds. Subgrounds really is the easiest way to query subgraph data. Using Subgrounds, you can easily load any subgraph across any network, any number of subgraphs as well, run queries, and then process your data in a familiar environment and get flat tables, data frames, charts in a very simple and intuitive process. So why exactly should you use Subgrounds? Again, it's easy to use. It's built in Python, so you don't have to work with the GraphQL strings. You don't have to understand GraphQL to use it. It's customizable. It's fully open source, which means that you can modify it however you need. It saves you time because you don't have to wrestle with the complex GraphQL strings. And of course, because it's built in Python and comes natively in your Python environment, you can use it with the tools that you're already familiar with, like Plotly and Pandas. So we think that it's a tool that everyone should use to do data analytics with your subgraph data. And of course, because it's easy to use and it's using the language Python, which is popular amongst data analysts and data scientists today, we believe that Subgrounds is really made for everyone. It's made for you. And that's why we're really proud of what Subgrounds is unlocking for data analysts in the graph community, and also just in the broader Web3 community, people who need that on-chain data to tell meaningful stories. So I'll give a quick demo on how easy it is to use Subgrounds. So in here, I have a Hex environment, which is just an online notebook where you can play around with code and see the results really quickly. And although I have some pre-compiled code here, I'm going to go ahead and just show you how easy it is to go from basically a blank template. So in this environment, it's just a blank cell, and generate some queries within a minute. So the first thing you usually want to do is go to the Subgraph Explorer and find something that's of interest to you. I really like the Aave V2 subgraph. So you click on that. And once you're there, you're presented with the normal queries in GraphQL. You have to look, okay, I think this is kind of what I want, but we're saying you don't have to do that anymore. You click on the URL, the GraphQL endpoint, you go to your environment and you basically just say, all right, let me first of all import my Subgrounds environment, right? And instantiate Subgrounds. And then in one more line of code, you load your subgraph. So in this case, I go here and say copy. And I say, hey, Subgrounds, load me this subgraph where the URL is this. So this matches up with the Aave v2 subgraph created by Masari. And once that's done, in Python, you can then construct your query. So in this case, I would say, hey, I would like to construct a query where I'll be getting the latest data, the last 5 data points for the markets and the TVLs for different pools in the Aave. So this query says, hey, when you query this subgraph, only get me the top 5 pools and pull the total value locked. And the beauty of Subgrounds is you can go from query to flat tables, which is essentially like an Excel spreadsheet, or we call it data frames in Python. You can say, hey, when you get that query, go ahead and flatten it. Flatten it into a table that I can read immediately. You run that, and it starts doing its job in the background. It's currently running the cell. It takes a couple seconds, and boom. We've gone from finding a subgraph of interest to presenting our data in a table. And now I can use this to do whatever it is that's meaningful to me in very few lines of code. It's easy to read and understand. So with Subgrounds, you're able to do really interesting and complex analytics, like what's going on with Rocket Pool. You load the subgraph URL, you construct your queries, you can do some math on the data. You can say there's actually some divisions and multiplications or arithmetic I would like to do on the data once it's queried. You can construct that in Python, and then you flatten your output into a table. So let me go ahead and run all of these and show you the power of how you can go from very easy queries to analytics in no time. So I'm going to run all of my cells, and we'll kind of just fly through some of the outputs. Let's go ahead and restart the kernel. Okay. All right, it's passing through. Awesome. Our tables are now being manifested right in front of us. So here we have a data table that shows us the financials for Rocket Pool for the last 30 days. And I basically did the same thing for Lido, financials for the last 30 days for Lido. Some more explorations on what's going on with the revenue at Lido. In this case, I'm looking at the cumulative protocol side revenue, supply side revenue, TVL, and I'm able to get charts. In this case, I'm leveraging an environment called Hex, which as of today officially has Subgrounds as a supported library within this environment. So anyone can go to Hex this moment, log in, and start using Subgrounds today in this environment. And through that, you're able to run your queries and have charts, meaningful data, tell a story in what's going on with Lido. Here's some more stories we can tell. In this case, we're looking at the usage metrics, seeing the unique users participating in this protocol. We can change how we view that data. And then share that chart with our community. This is the power of Subgrounds and how it allows you to do subgraph data analytics really easily. So how can you learn more about Subgrounds and take your data analytics to the next level? It's very easy. I'll share the doc links where you can go ahead to learn how to install it into your environment and get some basic examples to get started. In there, we show you how to construct your queries, what the equivalent Subgrounds query looks like in GraphQL, so that if you would like to understand the underlying GraphQL on the background, you're able to see the translation from Python to GraphQL and vice versa. And you're also able to play with the codes within the documentation. So it's truly an educational experience getting started with Subgrounds. And of course, we have examples for all kinds of analytics that people in our communities are using Subgrounds to create, from massively popular data apps like the one from Klima Playgrounds to deep research on MEVs, deep topological analysis on blockchains, snapshot for DAO proposals and DAO participation, and so on and so forth. You can also find video tutorials where we have live workshops that goes from zero to hero in this 3-part series and many more to come. So that's it for Subgrounds. And I hope you guys get to play around with it and tell meaningful stories with your subgraph data. Thank you.
Thank you so much, Sachi, for that. I was gonna ask you if people have questions where they should go, but Stoffer already shared the Playgrounds Discord, so I think that is where people should go if they have questions, right?
Yes, absolutely. We're always happy to chat. Stop by our Discord, and we're always there looking to talk to someone about data analytics using the subgraphs.
Awesome. I will make sure that we also share that link in the description of the recording. So if people see this and they get super excited, they can join at a later time. So once again, thank you so much for that presentation. That was really cool.
Thank you.
All right. For our fifth segment, I would like to pass the mic to Esti to do a quick introduction before the segment starts.
Thanks, Colson. Yeah, so for the next segment, I'm excited to welcome Pablo from EdgeNode. For those who might not know Pablo, he is a senior smart contract engineer who is engaged in developing protocol upgrades at the graph, which is a highly critical area as everything that we do to interact with the graph network, such as delegating, curating, or indexer staking, is happening via the graph smart contracts. Pablo has been heavily engaged leading the efforts in the L2 migration initiative to Arbitrum, and he is here today to provide us with an update on the progress. So thank you for joining us, Pablo, and the stage is all yours.
Hi, thanks so much, Esti, and thanks for having me here. I am going to share my screen. I have also some slides. Can you folks see this? Okay, great. So first, I know, probably a lot of you already know some or most of what I'll be presenting today, but I'm going to give some context so that everyone can have the same information, hopefully. So first, what does it mean that we are migrating to L2 or scaling on L2? Because those are the two ways we talk about this generally. And as Esti mentioned, when participants like you interact with the graph, there are transactions that happen through the smart contracts for the graph protocol. And these smart contracts have initially been deployed in Ethereum mainnet. So when an indexer wants to index a subgraph, or when a delegator wants to delegate some GRT and so on, all of these are transactions that happen through Ethereum mainnet. And what we want to do is deploy a new protocol, a new set of smart contracts, this time on Arbitrum, that is this layer 2, and provide a way to send GRT from mainnet to L2 and back to L1 if needed. And these new smart contracts are hopefully going to be the way in which all participants interact with the protocol in the future. But for a transition period, we're going to have both protocols running in parallel and using the bridge to send messages and GRT across if needed for certain things, which I'll explain in a minute. So this is kind of the transition period that hopefully will take only a couple more months. And eventually, then all of the transactions and everything that happens on the graph network could happen on Arbitrum on this layer 2. So why would we do this? The short answer is gas, and basically doing any transactions on Arbitrum is much cheaper than doing them on Ethereum mainnet. And this is an example from a few weeks ago. I checked a simple token transfer. Doing it on mainnet cost about $3, more than $3, and doing it on Arbitrum cost less than 10 cents. So we would have much lower gas prices that affects all of the participants on the network. But it also means that indexing is cheaper because indexers need to constantly allocate and close allocations, and these are all pretty complex transactions. If indexing is cheaper, hopefully this means eventually more indexers serving more subgraphs and hopefully also serving cheaper queries. So this is partly why we call this scaling on L2, because having these much lower gas prices means we can scale the network to a whole new level. But it also means we can do more things on chain. If we have a very high cost for every piece of computation that we do on the smart contracts, then this means there's only so much we can do in terms of the economic incentives and all of the mechanisms and everything that we do on the smart contracts. Now that we have much lower gas prices, that gives us a little bit more leeway to do more complex mechanisms or things that would be prohibitively expensive on mainnet. Obviously, we don't want to do something that's very complex and then we have the same costs that we had back on L1, but it does give us a bit more margin. So the plan for this migration is it's got several stages. It's not something that we can do very directly and just say, okay, we're going to deploy to L2 and now everyone is running on Arbitrum. We have the running protocol on mainnet, and moving away from that is not something that we can force or kind of instantly achieve. So we've started working on this, or at least coding the contracts for this early last year. And the first stage was deploying the L2 protocol without indexing rewards and deploying this bridge that allows sending GRT from mainnet to Arbitrum. This stage one, so we actually deployed it in December last year, but throughout Q1, the other teams have been deploying the Explorer changes, the Studio changes, and so on, and all of the off-chain components that make the network work so that we can have a fully functioning L2 network with this caveat that there are no indexing rewards, and this means there is currently little incentive for indexers to actually start serving subgraphs while operating all of their activities on L2. So the next stage is to actually enable these indexing rewards. We're right in the middle of the two stages because we're finalizing all of the testing for stage two. We're actually hoping that we can deploy the changes and enable a 5% of the indexing rewards on L2 as early as next week, hopefully. Don't quote me on this, but we're really hoping that we can do the deployment next week. So obviously this means council approval, but they're already voting on the changes. And these are several JPs, JP 37 and I think 43, if you're interested in the details. So with this change, indexing rewards will be minted on L2 as well as they are currently minted on L1. So this is new token issuance, but we're going to reduce the issuance on L1 to 95% of what it currently is and increase it in L2 to 5% of what we currently have on L1. So hopefully this will incentivize some indexers to start setting up operations there. And while this happens, we're also working on finalizing stage 3, that is the migration helpers that will allow all of the participants to start moving their state, their tokens, their signal, and so on from L1 to L2. And as we do this, hopefully we will also be able to increase the rewards that are issued on L2 while we decrease the ones on L1. And then most or all participants will end up moving to L2, and Arbitrum will be the place where the graph protocol runs. So just a bit more detail on the migration helpers and what might mean to some protocol participants. Basically, we're still finishing the audits and testing the contracts for this, and the UI for this is being developed. And obviously, it will need council approval, like all of the protocol changes. We've been engaging with them throughout the way. And these helpers will allow sending subgraphs, sending curation signals, sending indexer stake, and sending delegation from L1 to L2. And we will be asking the council, as I mentioned, to increase the L2 rewards as we release it. So far, it seems that we're going to release first subgraph migration and curation signal migration, and shortly later, we'll be releasing indexer stake migration and delegation migration. If you're interested in the details, you can check out GAP 46. The link is there. I can share it on the chat later as well. And I'm going to focus on how this affects two types of participants. First, for curators, the helpers will allow subgraph owners to send the subgraphs to O2. So a subgraph that is currently deployed to the graph network and it's being indexed and it's represented by some state on the smart contract on O1. This can be migrated, so the same subgraph ID will exist on O2. When this migration happens in O1, it will look like the subgraph was deprecated, which is an action that can already happen. If you're a subgraph developer, you can deprecate your subgraphs. And what happens is all of the signal is converted to GRT at the same time. And this means there is no rush if you're a creator to withdraw your GRT after the migration. It will sit there and it's not going to be affected by other people withdrawing. And obviously, the amount of GRT that you get is proportional to the signal that you have, which is in turn dependent on how you entered the bonding curve when you minted the signal initially. And then if you're a curator, once the subgraph that you were curating to has been migrated, you can choose to withdraw those GRT in L1 if you don't want to move to L2, or you can migrate that same GRT to the same subgraph on L2 using one of the helpers. So all of those GRT that you owned that are inside the curation contract or the GNS contract, they will be sent to the GNS contract on L2, and they will mint new signal on L2 for you. So you can keep curating to this new subgraph, but with a new bonding curve on L2 that, I don't know if you've been following the GAPs, but in L2, the bonding curve is flat. So it's always the same amount of signal for
Pablo, I think your mic is not working anymore.
progressively send their stake to L2. So they can send 100,000 GRT initially, and then later send 50K more and so on, and then finally move all of it if they want. But as soon as they send some of their stake to L2, and if you're a delegator, then you'll be able to send your delegation to that same indexer in L2. So the same migration helper, there's going to be a UI for this in Explorer. So you click a few buttons, do a transaction, wait for a few minutes, and then all of your delegation that you had on L1 is now on that same indexer in L2. So because of implementation details, you can only send your full delegation over. You can't send parts of it. So you can choose whenever you want to do this. But if the indexer migrated fully to L2, they don't have any stake left on L1. So your delegation is just sitting there without actually having an indexer. Then what we're doing is we want to allow skipping the unbonding period, so you don't have to wait 28 days if you don't want to migrate to L2 and you just want to withdraw your GRT. So if you have any questions, you can find me on Discord or comment on the GIPs on the forums. We're always keeping an eye out there. So yeah, that's it. Thank you so much.
Thank you so much for that detailed explanation, Pablo. It was very nice to see. And links to all of this were also shared in the chat room. So if you want to read up on this in more detail, check those out. For our last segment, it is about AI in crypto, and I would like to pass the mic to Sam Green, co-founder and head of research at Semiotic Labs, to tell us more about how AI is being used in the graph.
Hey everyone, thanks for having me today. So I'm gonna start by talking about some tools that we've deployed in the protocol today, and then some AI tools, and then I'll end with talking about how we see AI benefiting from the graph, and vice versa, how the graph can benefit from AI. So we've been involved in the graph. Semiotic Labs has been involved in the graph for 2 years. We have a team of AI researchers and a team of cryptographers. And on the AI side, we've been doing interesting stuff since the beginning. Initially, we worked with Brandon Ramirez, who's now CEO of EdgeNode. where we were working on using AI for negotiating prices, and we were using AI to study the how indexers are selected for receiving queries. And that initial research then eventually got focused into a few products that are deployed. One product is called AutoAgora, and AutoAgora is for indexers. And so when somebody submits a query, a GraphQL query to the graph, what happens is that the query goes to a gateway. And a gateway, you can think of a gateway as like a router. And the gateway is aware of all of the indexers that can serve that the data for that query, for that subgraph. And it's also aware of like the performance of the indexers and how much they're charging. And indexers use a tool called Agora to set prices. And Agora can set a specific price for each particular query on a subgraph. And so you can imagine that, there are literally an infinite number of queries that could be sent for a particular subgraph. And so it's a very complex decision-making process for indexers to set their prices manually. So Agora is a manual tool where an indexer has to say, okay, this query template has this cost, this query template has this cost, and so on. So a lot of our work in the early days was related to measuring the computational complexity of queries. And the AutoAgora is a tool where we automatically measure the resource costs. So specifically right now, what is the average latency of a query? And we use average latency on the indexer side, meaning how long does it take to collect the data from the database and return it to the consumer. So we use that as a proxy for query cost. And then we use that and we combine, that doesn't involve AI, that's just pure measurement. And then we use reinforcement learning, which is, you could think of it as trial and error learning, to select a price. So the indexers run AutoAgora, and AutoAgora measures the most common queries they're receiving for a particular indexer. It measures their most common queries. And then reinforcement learning is used to dynamically adjust the prices of the queries so that the indexers can maximize the revenue. So, going back up to a higher level, we view AI as a tool for optimization. And in this case, indexers shouldn't be spending a lot of time manually measuring prices, manually measuring their resource costs of queries and manually adjusting prices. That's not competitive for them. That doesn't increase their competitive advantage. Their competitive advantage, because that's very time consuming, and it's just not where they're bringing the most benefit to the protocol. So these tools are used to let them focus on other things that can increase the quality of service of the network. Okay, so that's AutoAgora. Another tool that we have is called the Allocation Optimizer. It's also a tool for indexers. And the indexers have many subgraphs that they can choose from. And one of the reasons that they'll choose a particular subgraph is because they get indexing rewards. And the indexing rewards are going to be proportional to the amount of signal that curators have put on a particular subgraph. So indexers, theoretically, indexers should index all subgraphs, but they can't do that because there's computational, like they have to create basically a new database for every subgraph they index. And they can't, it's very labor intensive to create all of these databases. So they need to pick basically, tens of subgraphs usually to index. And so the allocation optimizer solves an optimization problem for the indexer, and it helps them understand where can they get the most money, the most GRT, which subgraphs can they index that will bring them the most GRT. So again, this is a math problem, and we're basically providing tools. This tool, the allocation optimizer, is a tool to solve this tedious math problem for indexers automatically for them. And yeah, the allocation optimizer is built, by the way, it's a collaboration between Semiotic Labs, EdgeNode, and GraphHops. So, that at a high level, those are two tools that we've deployed and that we maintain for indexers. The AutoAgora for dynamically setting prices for indexers, and the allocation optimizer, which solves a optimization problem for indexers. Now, moving forward in the graph, we are just like everybody else. We're really excited about recent advances with ChatGPT, which is a name brand for what's called a large language model. And in general, the graph itself is even without ChatGPT, the graph itself has always been it was going to be powerful for AI. And so let me expand on that for just a few minutes. So at a high level, I'm really excited about applications like Chainbrain and Subgrounds because previously, probably most of the world currently still thinks of the graph as a way to store data and then retrieve data for front ends for dApps. But everybody on this call sees everybody on this call already knows probably and is definitely seeing today with Chainbrain Subgrounds that is not the only thing the graph is going to be useful for. And it's what I'm most excited about, or what I'm really excited about, is increasing, or I should say decreasing the complexity of using all of the awesome data that we have stored in the graph. And using LLMs in applications like Chainbrain really lowers the barrier to entry for people to make queries and to consume and analyze the data that we have in the graph. Similarly, Subgrounds is going to let data scientists be able to easily use the data that we have in the graph. And I believe that applications like this can bring us an order of magnitude or more in query volume. And the data is already there. We just need to be able to expose it. We're now exposing it to people through through tools like this. In addition, something that I expect to see happening more in the future is using the graph's data as a source for training machine learning models. With these tools like LLMs, ChatGPT, for example, you've probably seen that these things can make up data. And one of the reasons that they make up data is because they're trained on all of the data. They scraped all the data from the internet. And you know that there's a bunch of contradicting data on the internet. With the graph, the graph, all of the data is verifiable. And so the data, we basically have a clean source of data, and we can use the graph's data is likely going to be used, or it's likely going to be a very useful resource for training machine learning and machine learning models and neural networks. So yeah, that's a overview of what we're doing at Semiotic Labs and how we see AI being useful in the protocol.
Thank you so much, Sam. There was a question in the chat for you. How exactly is AI used in the allocation optimizer?
Oh yeah, that's a good question. So AI is adjacent to a field of research classically called optimization. So, in fact, AI uses tools from non-convex optimization, specifically gradient descent. And the allocation optimizer is not using any neural networks, but it's an adjacent tool. It's using methods from non-convex optimization to solve the allocation optimization problem.
Great. Thank you so much, Sam. And if people are interested in this, I would once again recommend listening to the GRT IQ episode 106, where Sam and some of his colleagues are at going more in detail about this topic. So thank you so much for joining, Sam. All right.
Thank
Before we end this community talk, I would like to invite everyone to join Indexer office hours number 99 today at 1800 UTC and the monthly core dev call on Thursday, March 23rd at 1500 UTC. I would also like to share with everyone the monthly core dev updates that were released on the forum. You can find them in the chat room right now. And as I said, all of the links that were shared in the chat right now will also be shared in the description of the recording. So I would once again like to thank everybody for joining. Thank you to our speakers and all the attendees. We will now open up the floor for Q&A. And if you have no further questions, I would like to wish you a nice day, and I hope to see you again next month. So thank you, everyone. And if you have any questions, feel free to ask them in the chat or unmute your mic. All right, I see no further questions, so let's end the call here. Thank you, everyone, and see you guys next time.